Hello, how are you doing, guys? How's it been with you? Um, I believe everybody's doing good. And welcome back to the session with Edu Ada. I believe you're going to enjoy this video. So please keep subscribing to my channel. Thank you for sharing already. Thank you for sharing. So today, quickly, we get to business. We are doing variation. Variation. What is variation? From the word variation, that's where we got vary. So if something varies, what happens? It means it changes. So variation basically is measuring relationship. It measures proportionality or the rate of proportionality or the level of proportionality. It measures what happens between two or more objects or bodies, like we say in science. So what is variation? It deals with the relationship between quantities. That is how quantities are related. That's what variation deals with. It tells you the relationship between two uh, exclusively growing items, things that are not related. They are just doing the test relationship between them. So that's variation. So variation tells us if we have a direct relationship between two things or indirect relationship, or it is not even direct and indirect. It could be joint, yes. And if it is not joint, we can have a partial form of variation between two or more objects. So this is what we'll be relating in this video, but in this particular video, I will streamline what we do here to just direct relationship with treat examples. Then subsequent classes of videos we talk about other types of variation. Now quickly, let's get to business. If we have this, ready, sorry, permit me. You have this. We want to talk about variation now. It's a variation relationship between two things. Variation symbol first. Let me indicate variation symbol. This is a symbol for variation. Others will draw it this way. It's not infinity, please. It is showing something varies. So if I say T varies directly as P, note this. This is a variation sign. So the first thing that you write in you will be given a problem in form of a word problem. A problem in a word form, then you translate it mathematically. So if I say, let's go this way. If I say that food consumed by Taiwo is directly proportional to its growth. If I say the food consumed by Taiwo is directly proportional to its growth. So what do I say? I said this: F, the food, is directly proportional or varies directly as its growth process. That means the more it feeds on food, the more it grows. So I have this varies directly as T. But if I'm to change this and try to solve it and know, okay, what if it fits on such amount or quantity of food? What happens to Taiwo's growth? So I can do, okay, permit me to change this. I want to change this. Instead of writing Taiwo, I will change it to G, directly to the growth. Sorry. This is food directly proportional to the growth. Direct relationship. Varies directly. That's F varies directly as G. So if I'm to write this mathematically, all I have to do is change the variation sign to equality sign. So I'm going to be having F will be equal to. I've removed this variation sign. The moment I remove the variation sign, I bring in equality sign. Then this is a what? There will now be a constant that will come up automatically. K will multiply G. So that means your F, the the more food he eats is equal to a constant times its growth process. Let's solve an example in this regard. If we have look at my example one. Okay, let me first explain this. Direct variation, this is a relationship with corresponding effect on the participating quantities. What does that mean? When increase in one brings increase in the other, that means if there's the more food Taiwo eats, the more food Taiwo eats, let me have something like this. The more food Taiwo eats, this is the food he eats, it will be equal, is directly proportional to Taiwo's growth process. So this is Taiwo. The more he eats, is that I've not yes, directly proportional to his growth process. So the more he eats, if he eats more food, is also directly proportional. It will not grow so fine. You can see that he eats more food, he grows bigger. He eats more food, he does not grow well. So there's a direct relationship. If he eats more, he gets more. If he eats less, it's not well grown. So that is a relationship. So if we have something like this again, we have this. Check this with me. So we have examples include A varies directly as B, and V also varies what? Directly as C square. C square. So when I say varies, I'm talking about P varies C square. Look at example 1. 1. X varies directly as Y cube. X varies directly as Y cube. So when you have something like this, is a direct variation. Directly as Y cube. It now says X is equal to 2. So before you write that, first write what this means. This means that X will be equal to K Y raised to power 3. Yes, you change the equalities and the variation sign to equality sign, and that gives you K times Y raised to power 3. That means the first quantity will be equal to what? A constant times whatever the second quantity is. So since they said K, and always have it at the back of your mind again, then you are solving a variation question, the first thing you look out for is your constant. So here you have your X. X is 2 already. 2 is equal to K times. My dot is representing multiplication sign, don't forget. 1 raised to power 3. And that's still what? 1. That means K will be equals to 2 divided by 1. And that is 2. So that means our constant is 2. Now we can solve any question we want to solve. Look at this. Oh, sorry. We can solve Constant means something that does not change. So far, there are other questions under this very question 1. Example 1, we keep using the constant to be 2. So the question now says, find x. We know before that x is equal to k y q. Right, the 3 there. Let's say find x. That means x will be equal to what? 2 times, what is our y now? Our y is 5 raised to power 3. Y cube is not 5, it's y that is 5. So y raised to power 3. So your x will be equal to what? 2 times 1, 2, 5. And that means what? 5 times 2, that is 10. Keep 1. 2 times 2, 4 plus 1, 5. 2 times 1, 2. That is 250. Is that clear? So our x is 250. Please follow me as I solve example 2. Very, very important. Example 2 states that we have a question like this. I want to wipe this, please. Please permit me to do that. So let me wipe from here, so that I can have sufficient space. Yes. So I have this. So the next question is, if the volume of a cone is decreased by 20% and the height increased by 10%, how is the radius affected? This is a word problem but related to variation. So the first thing you write the volume. What's the volume of a cone? V should be equal to 1 upon 3. Don't forget, volume is what? The base area times height. And a cone is of this nature. So we talk about this base area, which is a what? It is a circular face. Then it has a particular height. So that will be 1 over 3 pi r square h. The radius area of a circle is pi r squared then times the height. Because it's a cone, it carries 1 over 3. Assuming the cylinder now, we just add this pi r square h. That will be 2 pi r square h. So let's continue. So this is your V. Now, take this one as V1. This one will be V1, radius 1, height 1, because there's a change. There's a change. So V2, what is said there is that what? There was a change. If the volume of the cone is decreased by 20%, so that means if it's decreased by 20%, that V2 will now be what? Will now be 80%, 80 over 100 of V1. Yes, so that will be 80% of V1. Since it has been decreased by 20%, so V2 will now be the 80% of V1. Then what? The height increased by 10%. H2 will be what? If it increased by, the height initially was 8, it increased by 10%. Now it will be what? 110 of H1. So that will be 110 of H1 divided by 100. So this cancel this. 2 here 4, 2 here 5. This cancel this. Nothing goes there again. So you have. Now what we are looking for is what happens to our R2. Our R1, you don't forget, from here, R1 should be equal from this first equation. R1 should be 3 V1 over what? Over H1. That will be the square. That's what R1 should give us. So having done that, what do we have? Our H2 is already giving us that. So what happens to our R2? Our R2 over what? So you go there, you write it out. Then you write, since your V2, you can write it the way it is in the formula. So you are going to write 4 over 5. 4 over 5 over 5 V1. That's what V2 will be equal to 1 over 3. I'm writing it in form of the formula now. 1 over 3 pi, then R2 squared. R2 squared times our H2 is 11 over 10. 11 over 10 of H1. And that can be equal to what? 2 here. Okay, multiply both sides by 5. Let's multiply both sides by 5. If you multiply both sides by 5, this one will go. This one will be left with 2 here. Yes. So 4 still remain there, please. So what do we have? Everything becomes let's make R2 subject of formula. So that implies that what? 24. This times this is 6. Okay, let me write this out. So I have 4V1 to be equal to pi R2 squared times 11 upon what? Upon 6. And that means R2 squared can be equal to what? By the time you cross multiply both sides by 6, you're going to be having 24V1. Sorry, I'm having 24 V1 divided by pi 11. Then this is squared. Let me clear this place so that we can continue from here. So having done that, what do you have? You're going to be having R2. You take the square root of both sides. Will now be what? The square root of 24V1. Please, this is V. This is V. V1 upon pi 11. So having done that, look at R2 and R1. I said my R1 is equal to this. This is 24. This is 3. So 3 times 8 will give us 20. And this is H1. This should be pi. There should be pi here. Should be pi here. Then pi H1, right? This is pi 11, isn't it? So that means I can write my R2 in terms of R1. Yes, I can write that in terms of R1. That means R2 R2 can be equal to what there? Have to be equal to 8 times everything, 8 over 11. Okay, 8 times 3 V1 upon 11. Yes. So I have 11 times pi h1. Yes, times pi h1. And that will be h times 3v1 over 11 times pi h1. And that can be equal to what? You can separate that by having square roots of 8 over 11. Yes. Then times the square root of 3 v1 upon pi h1. Now pi h1, then what does this mean? This implies that, check, let's continue from here. This is where you can get what happens to R2. Without this part, you can't get what happens to R2. You can't. It's where you decide. So yeah, you can rewrite this as, or this implies that the square root of 8 upon 11 times R1 is actually less than R1. And what does that mean? Therefore, I can say the percentage change permits me to write my change in this form. Percentage change, at symbol means change, can be equal, open bracket, 1 minus then the square root of 8 over 11 times 100. And that can be equal to what? 0.147 then times 100. And what would that give us? That will give us 15%. Check your calculator. Approximately 15%. Because that will give us 14.7. That's approximately 14%. And what does that mean? Hence, I can say, hence, 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 the radius, hence, the radius decreased by 15%. So that is the answer to the question. It's an application to variation there that we just done. Thank you for stopping by. I really appreciate you. I hope you have a nice time. Yeah, if you have any question, comment, you can make a comment on this my channel, on the video. Make a comment. Have any question, send it to the, you make use of the comment box. Any clarification, any assistance on your work in mathematics, reach me out. Or you can reach me on this number 081 64 86 94 9470. Thank you for standing by. See you guys in the next video.